Well, here we are, I'm back. Long while since I've done a video, but this is my latest project. I'm just in the process of finishing off. It's an SMD Reflow system, so we've got two hot plates on the top there. The front one's in use at the moment. It's flashing red because the temperature's over 80 degrees. We've got a display down here with an encoder. That's showing the temperature profile for the solder that I'm using, which is Chipkick 165. It's a T5 solder. You can see that the temperature, which is the solid area, is following the profile. It's a little bit behind, but so we're now up to set point's 156 degrees, the front plate's at 135 degrees, and the rear plate's at 30 odd, because that one's not being used at this point. We've got 300 seconds to go before the profile finishes, and I've got a plate on there that's already been soldered, but I've just put this on for demonstration purposes. So as well as doing a number of different temperature profiles, the device will also just do a constant temperature run. You just tell it what temperature you want it to go to and how long you want the run to last, and it will do all of that. Now we're just about to come to the point where you might have heard the fans come on there, because the temperature profile is now finished and it's ramping the temperature down. Right, so we'll wait for this to cool down and then I'll give you a run around the box and show you how it works. Okay, the profile's nearly finished. If we look, we're down to 20 odd seconds. You can see how well the temperature has followed the required profile. The board is cooling down. The lights are now just solid red because the temperature is below 80 degrees but above 45. We're down to 4 seconds. 3, 2, 1. There we go. The profile run is complete, and shortly those lights should go green once the temperature gets below 45 degrees. There we go. That's the run done. So let's have a quick look around the box. As you've seen, we've got an encoder with a switch there and a 128 by 64 two-color LED or LCD display. Got the fan on the side here. Got a USB connector here so that the firmware can be updated if we need to. Around the back we've got an IEC socket, fused and switched. Around the other side we've got a big vent there for the fans. On the top we've got two 400 watt hot plates. You can either use just the front one or both of them, and the firmware and the hardware both actually support up to 4 plates. In this configuration, because we've only got 2 plates, then we've got a red and green dual color LED, 2 for each plate. But if this were to be a 4-plate variant, then we could have 1 LED per plate. Now the software and the software and the hardware has been designed to be used with a single plate, 2 plates or 4 plates. If we just have a peek at the bottom, there you go, nothing to see there, just the plates. This is holding on a PCB which holds the ESP32 controller, and these ones are holding on a 5-volt power supply, and this is the earth screw, so all of the metal elements of the device are fully earthed. And there is also a thermal cutout, so if the temperature internally reaches above 50 degrees C, then the power is completely removed from the device, apart from obviously the earth cable. Just to show you the user interface for driving the SMD Reflow hot plate, at the moment it's off, and that's showing the front and back temperatures. The 27 is just the number of frames per second that are being displayed. So I've got a profile mode, a constant mode, and a test mode, and the test mode allows you to calibrate the temperature profiles for each of the plates if you want really accurate temperature measurement. So if we go back to profile, okay, so we can go up, we can pick which profile we want to use, and the star shows that that's the field which is currently being edited. And there you go, we've got a number of different temperature profiles we could use. And so I'll go back to the chip quick one, which is the one I usually use. We can then determine how many plates we want to use. One, which will be the front, or two for both. Pick that. So we can now do go, and go, and that's it, we're off. So that's the temperature profile actually running. Right, the plates will be coming up to temperature, as you saw before, but if we want to at any time we can abort the run just by hitting the button. That's it, it's aborted. And if we want to do a constant run, that shows what the target temperature is, so we can go and change that if we wish to 170 degrees. How many plates do you want, and the number of plates that are suggested in the constant mode and in the profile mode are just variables that can be defaulted within the software. So if we change that to 1 plate, and we then get the choice to choose duration, and that's the duration for from the point we start ramping up the temperature to the point we start ramping down the temperature. So we can change that down, so 240 seconds say, and then do go, and again, and there we go, that's what we're going to do. We're going to ramp the temperature up. Right, we'll just watch this until the temperature starts to rise, and then we'll abort this as well. So you can see there the front temperature is ramping up. Okay, there you go, front plate's gone over 40 degrees, sorry 45 degrees, and up to 67, 70 odd. Okay, so it's now over 80 degrees. As you can see down here, the temperature is ramping up. Now the device uses PID control, and I'm still in the process of tweaking the parameters to try to get the control as accurate as possible, but it's not something I've ever done before, so I'm not perfect. So if you watch this, this is going to overshoot. There you go, so we're up to 158, 159. Okay, so we've exceeded the set point already, but the outputs will now be off, so the temperature will start to stabilize and then start to fall, and then the PID control will kick back in again. What we'll do is we'll just abort that, and you might have heard the fans ramp up there, because when we go into cool down mode, we want to get the temperature down as quickly as possible. So we have an example PCB on the Reflow plate. I've just populated a few sites, so we've got a 4067 analog switch there. We've got some resistors, we've got a few Schottky diode pairs and some fuses, and all I'm going to do is, there's the screen on the reflow plate. Just going to go for profile option. We've got chip quick 165 T5, and that's the solder I've used. We only want 1 plate because that's plenty for the size of PCB we've got, and we'll hit go. So the fan started. At the bottom there you can see the set point is at 45 degrees. The first 30 seconds or so is just at 45 degrees. And then just above the 25 degree C lower limit point there, you can see the temperature is starting to be plotted. The temperature on the front plate is now up to 30 degrees. It's starting to climb now. It's now up to 130 degrees. So we'll now start looking at the components. Let's get a bit more light on the situation. Front plate's now up to 140 degrees. I'm beginning to smell the solder starting to melt. Front plate's now up to 155. 162, 3, 4, 5. You just heard the fans come on there. That's because we've reached the cool off point. So the fan that's underneath the plate is now blowing quite strongly to cool the plates down and to actually cause the temperature to fall in line with the temperature profile specified for the Chipquick 165. Okay, so I'll pause that while we wait for the cool down to complete. Okay, so the front temperature is down to just, what is it? 79 degrees, so the lights have gone solid now. Still got 120 seconds to go. As you can see, the profile of the heat up period almost exactly matches the required profile for the Chipquick 165, though a little delayed. I'm still working on getting my PID values properly tuned in, and I'm sure I can get that even better. And at the moment I'm also restricting the heater elements to 15,000 out of the 4,096 PWM steps per second, so I'm only at about a third of the capability of the hot plates, so I'm sure I can get the responses even better than they are at the moment, but it's just a case of tuning things. So if we look at the chip there, try to get into focus. Yeah, that looks fairly well soldered. Let's do those resistors. Let's do the Schottky diode pairs on the fuses. So I'm quite happy with that. So that's the profiled in to be complete. Pop up, we should see the LEDs go green any second. There we go. So that's the profile completed. That's our soldering job done. That looks pretty good. And here is the circuit board after it's cooled down, and I'd say that looks just about perfect. All the joints look to be really good. Got no excess solder, got no bridging on the IC there. Yep, happy with that. So, what do you think of my SMD reflow solution? In the next video I'll show you the 3D design in Tinkercad. I'll show you the PCB schematic in KiCad, and we'll take the box apart and have a look at it, and show you how it works, and maybe have a look at some of the code as well. Bye!